This is part 2 in a series of videos in which I will be repairing, or hopefully repairing, this pair of HP9100B calculators. These were sent to me by someone in the US, so they've had a bit of a bumpy journey over here. He packed them incredibly well, so it looks like they have survived. I'm not sure about the CRTs yet. I haven't tried powering these up. What I've done so far is just open the top covers, they're not screwed down, and I've had a look inside. In the box that this one came in, there were some bolts in the cardboard box it was in that appeared to have come out of this machine. And it's not that unusual for parts to get shaken out in shipping, and what I do is, before I power them up, I have a look through and make sure there's nothing that's sort of dropped into a place that could cause a short or other damage. Also, the nature of failures we can get on these because of this CRT can cause damage to the boards. So I've just used the multimeter to do some basic testing and make sure that we don't have anything obviously wrong. I haven't dismantled them, I haven't taken the boards out, I haven't done anything else. I've just had a cursory look inside to see what's going on. So what we'll do now is power these up. And for this video, all I'm going to do is try each one and try and assess what the general state is, whether it actually runs, and the amount of work we're likely to need to do on each one. Either way, I will be stripping both down completely, giving the boards a good going over and making sure there aren't any issues lurking. Because of the nature of the circuits in these, they are quite prone to suddenly stopping working if something isn't quite right. So we'll start off with this one. I'll get this one out of the way, we'll power it up and see what happens. Okay, so starting with this one, there is a sticker on the top and it says screen glows, no activity, error light. Something clear, I'm not quite sure what that says. There's no light on here, that should be around here somewhere, that comes on if a process is stopped halfway through or part way through. Just acts as an error light to show that something couldn't complete. When we power this up, what we should see is, normally there's a display here, but this display panel is not in the machine at the moment. It is in the box, but it's not fitted, so there are no lights, so we won't get anything in this area. Normally it lights up, but we should get the CRT displaying the contents of the three main registers. That's the X, Y and Z. I'll come back to what they are if you're not familiar with this machine later. So we'll power this up. I have switched it to 230 volts. As I say, it came from the US. Now, one of the issues that we are likely to see with this is that the CRT displays information in a vector form, so it kind of draws what are like 7-segment display characters, alphanumeric characters, but it actually draws them as vectors, kind of a bit like you would with a pencil if you try to draw something without taking the pencil off the paper. And it draws them in a bit of an odd way, but it blanks certain segments to create the different characters. It always draws or goes through the motions for all 7 segments for each character, but it blanks the beam on the CRT for certain segments depending on what it wants to draw. To stop the image wavering about, as I say, it's a CRT, and if you saw my video on the ADM terminal, I mentioned in those videos that the display is synchronized with the mains frequency, and that's to stop the display kind of undulating if there are magnetic fields or hum on the supply. And these work the same way. The display update is synchronized with the mains frequency, and that has an unwanted side effect. If you move one of these from, say, the US to the UK, then in the US it was running at 60 Hz, so you had a 60 Hz update for the display, but in the UK we're at 50 Hz, so the beam will be moving significantly slower for us than it would be in the US, and the upshot is you normally need to adjust the brightness and possibly focus when you turn these on, but it shouldn't stop the display coming on. The reverse is not necessarily true. If you move on from the UK to the US, it may appear that the display is blank, but it could just be the brightness is too dim because you're now moving the beam so much faster. But we'll see what happens when we turn it on. Chances are it will do nothing at all. That's what they normally do. It says the screen glows. I don't know if that means we get characters or if there's just a background glow. And also, of course, we don't know if the tube works at all. I haven't checked the supplies. I haven't done any other tests other than the static testing, and so it may just blow the fuse. Okay, so we'll power it up. Okay, it's drawing about 0.4 amps and the error light has come on. So we'll just give it a minute or so. It is a CRT, so we need to allow CRT to warm up. I'm just going to momentarily dim the lights. I think I can see a green glow, which I can. I don't know if you can see it on camera. There's a green glow across the bottom of the screen, so it's not scanning the screen. We may be able to provoke it into doing something. I'm keeping an eye on the current being drawn. If the process starts up, the current should come up, but we should be able to get it to do something if we can provoke it into running a routine of some sort. Now, one of the issues with these machines is, and it's kind of a good thing, bad thing. If you've seen my series of videos on the magnetic core memory system that I developed recently, one of the features I built into it, which is common in pretty much all magnetic core memory systems, is that because the data is held in magnetic cores, then if you turn the power off, the data is not lost. Now, this machine uses the core memory not only for data, but also for status flags and the instruction pointer, that sort of thing. So if you turn the power off and there was an error, you won't clear the error just by turning the power off and back on. It'll just come back up in exactly the same state that it was. So sometimes this sort of thing is as simple as it encountered an error and all we need to do is try and clear the error. So of course it could be that it's not working at all. So we should be able to find a process that we can abort. So I'm keeping an eye on the current being drawn to see what activity may be going on, and it should be possible for us to get it to run a particular routine that will hopefully get it to come out of whatever loop it's stuck in, if it's capable of running. What I'm trying to do is get it to come completely out of whatever routine it's in. I think it's actually running because the glow is going all the way across the screen. It's not just in one area. Normally we'll get just a dot in one area if the beam's not moving. Because we're getting a glow all the way across, I suspect it's working out. It could be the tube has failed and it's not able to provide vertical deflection, which is not that uncommon with these. So what I'm going to do is power it off and then fairly quickly power it back on, and I'm going to turn the lights off first and we'll see if we get any scanning whatsoever in that process, and it might give us some clue as to whether this is capable of actually providing a vertical scan. So we'll turn that off, turn it back on. Okay, so this is what I was talking about. You'll get a single dot. Okay, well that's obviously different, so it's now looking like it can at least provide some kind of vertical scan, and that's now disappeared. So I think it's partly running, but it doesn't look like the tube is largely functional. I think the scan boards appear to be working as well. It's the deflection boards I'm talking about. But it appears as though it's not able to successfully run any particular instructions. What I'm going to do is adjust the mains voltage a little bit. As I said, sometimes it can be as simple as it may be something's running on borderline with regard to memory timing or supply levels, and that's the kind of nature of the issues you get with this. It might provoke it into doing something slightly different. So I'm going to reduce the voltage to 220. I was on 230, and we'll try and reset. And indeed we do now have a display of source, very blurred and over bright. What I'm going to try and do while that's on the screen is adjust the output to drive the tube, see if we can get that display any better. Okay, I'm going to raise the camera so that you'll be able to see what I'm actually doing before I start. Okay. So what I'm going to do here is there's a focus adjustment. So I'm going to try and tweak. Okay, that looks much better. And I'm going to bring the brightness down. I suspect because it was on 60 Hz that it's just too bright. So if I can turn that down a bit. There we go. Okay, that's much better. So I'll lower the camera again so you can see what's going on. Okay, well that's got the display on to a certain extent. All I've done so far really is adjusted the mains voltage. The power supply on these is adjustable, and it is fairly critical that it's correct. Again, if you've seen my series on the magnetic core memory, then that will tend to explain why that is so critical. And if it's not adjusted right, then you will get all sorts of problems, and chances are it will get part way through a process and just crash, which is what we were seeing. What we'll try doing now is just pressing some keys and see if that kills it. So what we've got here are the displays of the three registers, and when you type into the keyboard, it should enter the data into the X register. Okay, so what we'll do now is try and press some keys and see if we can get any type of response. I suspect what will happen is it will just crash, and that could well be what was wrong with it in the first place. Also, I've only made a very arbitrary adjustment to the mains voltage, so chances are it's still a long way out, and the power supply needs adjusting, so I'm not expecting a great deal here. Okay, well, this may be what he meant by screen glows no activity, so that's quite interesting. What I'm going to do is increase the mains voltage again and see if that changes what's going on. Again, that will give us a clue as to what may be causing this issue. So we're back up to 230 volts. Okay, well it looks like the processor's not really running. The scan circuits seem to be up and running. It's displaying whatever happens to be in the registers. I'm going to try and turn it off and back on and see what happens. And we've gone straight into an error light. We'll try it one more time. And same thing. So we'll try it again with the mains voltage turned down. And we're getting the same thing. So it's obviously not happy. There's a lot of work that we're going to have to do but at least it is partially working, so that's a good sign. No smoke, and the supply current has been fairly consistent, so that's quite a good sign. It means that quite a lot of the machine is functional, but clearly it needs some work. So we'll get the other machine brought over and see what state that one's in. So that's the second machine. This one just says no activity on it, so turn this back up to 230 and we'll turn the power on. Again, I've checked this internally to make sure there's nothing obviously wrong with it. Okay, and that's drawing absolutely no power at all, so the input current is 0. Let's check we're properly plugged in, which we are. And the switch feels okay, but it could be that it's not making contact, or it could be a fault with the socket or the supply. So clearly there's nothing happening with this at all. So I think what we'll do is we'll start with this one, and I'll start looking at it inside. Before I start to dismantle it, I'll have a quick look around, see if we can figure out why it won't start up, and we'll go from there. So we'll have a quick look inside this, and I'll just point out the main features of it before we go any further, so at least you've had a look inside and you can see what type of construction this is. Okay, the top's not screwed down. I didn't unscrew it, it was already unscrewed, and this is a stop very similar to the HP98 printer. Okay, so what we have inside, let's move the camera. Okay, we've got the CRT on the left here, along with its 2 drive boards. That's the drive boards for the deflection. We've got a big power supply on the right here. Now, of course, I don't know if any of this works because it's not powering up at all. And we then have the main boards. I say the main boards, these are kind of the logic boards, and the interface boards for the what amounts to the processor. One of the weird things with this machine, and you probably can't see it at the moment, we'll have a closer look in another video, is the bottom of the motherboard, or what would normally be a motherboard on this, and there are literally thousands in this machine, and these boards, which are really the control logic boards, plug into that, but a lot of the logic is diode logic, diode steering logic, and most of that is catered for on the actual motherboard. So a lot of the logic control of this is by virtue of the data paths that are formed by all these resistors and diodes on the motherboard, and the function of the boards that plug into it is fairly specific to parts of the control system, but it's not like on a typical system you'd see these days where the boards would contain all the electronics and then the motherboard is just there to connect them together. The motherboard in these machines forms a great deal of the logic brains in the system. And then what we have here are we've got the this is really the Microcode Rom Board. This is what in the 9830A would be the Microcode Rom Board that contains the small mask ROMs. And then we have various boards, and these contain flip-flops, which are really the logic elements that are used. And then we have the RAM boards and the control for the RAM board. The actual main ROM for this machine is underneath the motherboard. There's another layer of boards underneath this, and that's what these short boards on the side do, called sideboards for probably obvious reasons. But even they contain some logic as well, but they're largely to connect the motherboard down to the ROM board underneath, and we'll take a closer look at that in a future video. What I'm going to do is just have a quick poke around, see if I can see anything else that may be causing this to not start up at all. This might be a lead come off. I don't know if this is exactly what the state was when it was sent, or whether something's been damaged in transit, but we'll have a quick look and see if I can find anything untoward. There are 3 fuses here. You want me to see them, but there are 3 fuses, so I'll pop those out, have a look. There's a main regulator back there that's formed using a 2N3055, and again, that might be at fault, but I suspect that's not the case because we're getting no current draw at all, so it looks like something just simply isn't connected. So I'll have a look around, see what I can find, and we'll get back on camera and see if we can get any further getting this to at least light up. Okay, well, the main incoming fuse was blown, so that explains why it wasn't drawing any current. Obviously it's not a good sign. It may just be as simple as the capacitor needed reforming, or had been off for a very long time and mains was applied to it without allowing the capacitor to reform at all. The fuse doesn't appear to have kind of failed catastrophically. It's not all kind of arced and blackened inside, so I don't think it was a dead short or anything like that. It just seems to be an overcurrent stress failure. So I've replaced the fuse. Actually put a says 1 amp at 115 volts. I'll put a 500 milliamp fuse in. We're running at higher voltage here, so the current should be less, and also it will hopefully protect the machine if there is a short. Even so, what I'm going to do is turn the mains voltage right down, power it up, and then slowly increase the mains voltage while keeping an eye on the current. I'm just going to close the lid as well. I don't know if the tube has failed. I'm a bit concerned. In fact, on both machines what I found is this mounting bracket at the back is fractured. It's cracked all the way through, and they both look like fresh breaks, so I'm a bit concerned about that. It may just be that these bolts were over tight, and that's fairly common, and because it's kind of a clamping system and the plastic ages, if the bolts are too tight it does tend to crack after a while, but it can take out the tube as well. So anyway, I'm going to close this lid down, we'll get it powered up and see what actually happens. Okay, we'll turn the mains all the way down and we'll start to increase the current. It shouldn't really go above about half an amp. If it does, then we know we've got a short of some kind. The power is switched on, this by the way, so the main switch is on. I did take the keyboard out of this, so the keyboard isn't screwed, but it is connected. I just wanted to check the power connector had been properly plugged in, and it wasn't just the case of the switch wasn't connected to anything. Okay, well, it's not dead short. We're up at 90 volts. We're drawing 1/4 of an amp, and the display, this is just a couple of incandescent bulbs that are behind there to give this display. It's just really labels for what each of the lines on the CRT mean, and that's starting to light up, so we are getting power now. So what I'm trying to do here is to see if the CRT is working at all. It appears that it is. We are getting some activity on the CRT. I'll turn the lights off and hopefully you can see what's going on. I'll keep raising the voltage. And as you can see, it's very sensitive to changes in voltage, so it can be sometimes as simple as the power supply needs to be adjusted. So we'll see if we can provoke it into doing anything. Keyboard's moving. Like I said, it's not actually screwed in at the moment. I've taken the screws out. Okay, well, it is able to run through certain processes to a limited extent. It's obviously not doing what it's supposed to, but we don't of course know why the fuse blew. The current is a bit higher than I would expect. It's slightly over half an amp. It will be higher on this one than the other one because we do have the lamps in, although I wouldn't expect that to make too much difference. Let's go up to the full 230 volts. Incidentally, the keyboard is quite nicely laid out for functional purposes as a calculator, but it's also quite useful in the way that they're laid out for fault finding, in that they do perform different functions internally, and sometimes it is possible to try and figure out what's going on. Depending on which keys work and which don't. Okay, so there's nothing at all there. We'll turn this down to 220 volts and see what effect that has. Go down a bit further. Okay, now you probably can't see this, but pressing certain keys does have an effect. So it is doing something, it's just not doing what you'd expect it to. But that is the nature of these machines. They tend to be upset by even fairly minor things. And in particular, they are very sensitive to power supply settings. So that will be the first thing we'll look at once we've been through the machine and given it a good inspection. So, okay, well, it's looking fairly promising in as much as we are getting something on the CRTs. So the CRTs aren't totally destroyed. Don't know if they work internally, of course, if the deflection plates have fractured or at least their supports. This is scanning up to a limited degree. It's very touchy as far as what's going on, but you can see it is actually responding to key presses. Now, this may only be because when you press a key, it's going to have some impact on the supply and power supply, and it might just be that that is what's triggering it to do something peculiar. It might not actually be responding to the key press directly, but even so, the fact that we're getting some element of scan on the CRT is a good sign. The fact that some of the keys actually change what's on the display and the nature of the display, albeit in a very minor way, is also quite promising. But in both machines, they're clearly not running the processes properly. And so, first step with this one is I'm going to check the power supply out very carefully and see what's going on there. And from that point on, we'll start dismantling the machine, take it apart into its major blocks, and then we'll start trying to figure out what it needs in order to get it working. But either way, as we go through, I'll explain exactly how each circuit works and how to go about trying to fix them. And these are, as I said in the previous video, very interesting machines to work on. Okay, I was having a bit of a poke around inside here. Just as I say, I will dismantle this completely. We'll go over the entire thing in a lot of detail. I was having a poke around and I popped out the logic control card, which is this one on the left hand side. We'll have a close look at that in a future video. And it contains a rope memory system. It's kind of an unusual in that it uses wound toroids rather than just simple core arrangements, but as I say, we'll look at that in a future video. I noticed that one of the wires that form part of the rope system, it's essentially one of the wires that create the memory storage elements within that rope, was broken, and so I've fixed that. Basically it was broken probably 5mm from the end. It looks like it's been poked and prodded a bit, and one of the wires had snapped off, so I reattached it. Luckily there was enough left on it to re-solder it to the board, so I've reattached that and powered it back up. And what we have now on the display is obviously far better than what we had before. So I'm just going to adjust the brightness. It's too bright again, which again it's not surprising because we're on 50 Hz here, so I'm just going to turn that down a bit, get a slightly better display. Okay, so that's at least now doing something. It is scanning reliably. It wasn't before. We're at 230 volts as well. So we'll just now see if any keys actually do anything, which they do. Not turning that, but they appear to be doing the right thing. So that was quite good. That's as far as I'm going to go in this particular video. It looks like the main reason this wouldn't scan anything on the tube is because we had some damage to the what amounts to the microcode ROM, and now that's up and running, so it's probably going so far through one of the program steps, the microcode steps, and then stopping. I'll go over how all that works in a completely separate video. I'll do an entire video on that because it is a very interesting part of the machine. But at least it's now doing something that appears to be fairly useful. As I said, it says no activity on the sticker, so chances are that's what was causing the initial problem. Most likely there will be numerous other things that we'll have to sort out to get this working, but at least we are now getting something a bit more along the lines of what we'd expect to see on the display, and it's actually responding to our key presses, so that is good as well. So in the next video what we'll do is start looking to see just what level of operational completeness this machine has, whether it's actually working at all. It's working to a certain extent, but we'll need to go a bit further to determine if it's behaving the way it should do. Okay, well, it's looking quite good. So that's it for this video. In the next one, as I say, we'll start investigating this particular machine. I'm not going to start swapping boards between the two machines, but the good news so far is that the CRT seems to be relatively intact. It's able to scan. The display is looking quite good. Now I've adjusted the brightness and the focus, it's looking quite good. And most importantly, it is centered, meaning that the CRT is quite likely intact. I'm going to slacken off the mounting bracket tension a bit just to make sure the tube isn't broken by the retaining bracket. Okay, so as I say, in the next video we'll start going over the various functions on this particular machine and see if it actually works.